So next up is a very common chart that is not immediately, given by pandas, but we can just use a few lines to get it done. And the two things that we are looking at will be multiple plots. Okay, we did multiple plots just now. Multiple plots, like this, can simply be just directly one command, and df.plot will handle the rest. So each column is a new line or bar or whatnot on the same axis. So that is clear. What is new here is that there is a secondary y-axis here. So for example, in a stock chart like this, we see stock price C fluctuating up and down, right? We can plot a line, trend line. We can plot a volume, the vertical bars. But it would be much nicer if you can see them together because, for example, it shows that the price is very high, but it's not much traded, so don't worry about it. Okay, price is low. Everybody went in to buy, is it? The volume seems very high. So it gives us sort of additional perspectives when we can overlay them together. So how do we do that? And how do we show the y, the additional y axis? Okay, so the idea is we want to display them, and for the sake of making sense as a stock market chart, I multiply B by 1,000 times, so the volume are in thousands, makes more sense. And then we reset the index, all right, so that the dates actually go back to the column. When we say reset index, in place is true, the dates in the dot index are moved out and sort of inserted into the column. So the index doesn't mean resetting the current date index to 0123. You can do that if you say uh, uh, discard or drop equals to true, right? So you basically just drop it and rename them to 0123 until the end. But what we want is to salvage the contents, the date contents in dot index. We could have produced a new date range, but what I want to show you is, can we do a one operation? Just move that index back to the column, right? And kind of reset it to 0123. Answer is yes. All right. So do it in place directly on our DF and move index to new column. And that column name is automatically called index. So now we can change the name, right? So we are going to rename them. All right. And again, in place is true. And now we are able to locate days, C, and volume. So DF2 now contains 3 columns. Days, which is the date that is moved from dot index and now renamed as days. C, the original chart price, and volume, the bars. So have a new figure, and all we need are 2 lines. One line to draw the C, the stock price, all right, and we say kind is line, style is star dash. Now this one really got me a lot of trouble because when I put circle dash, because I thought idea is circle and dash, right? Circle, marker, and line. Some versions of PyPlot didn't like it, and that gave me a lot of blank or else wrongly drawn chart. So pay attention here. Star dash. If you want to be super safe, you can also say marker equals to circle, and that will be okay. Then we have color orange. Use index false. This is super important. Use index false. Don't use the index. The index is 0, 1, 2, 3, right? But don't use it. If you use it, you will only see the first one, not the second one, or else the second one or not the first one. So there's a problem there. So use index equals to false, and then second one has a little bit of twist other than the requirements, like x equals to days, right? Y equals to volume, you know that. Kind is bar. Ax equals to the previous ax. So the left-hand side ax is the attribute value, the input parameter name, the named parameter for df plot. The second ax is the variable name that we have here, which is the axis pointer returned by the previous plotting of the orange stock price. So we say where to plot. Can you plot here? We are pointing at the price, the C, column C axis. So we are instructing the dot plot to plot in the same axis. This is how we achieve it, right? Next thing is also, but if you plot in the same axis, could the dot plot erase the previous one and overwrite it? Possible. That's why we say use index false. Don't use back the same index. Just blindly plot on top, because we know that the days are already aligned, right? Because each row, the columns are aligned. Uh, that volume occurs at this price is on this day, right? So it's all aligned. So we don't need additional alignment using the automatic axis, the index alignment. Next is alpha equals to 0.3 and color blue, uh, just the aesthetics. More importantly, secondary y equals to true. Show us this volume, because otherwise you'll be wondering, volume equals to $6? That's strange, right? So we need a secondary y. Yes, this is the one. So in the second dot plot, two new things, very important. Ax equals to ax, secondary y equals to true. You must have that. Then for this, for both df dot plot, always include use index equal to false. Equal to false. Very, very important. Right? Finally, because we use index equals to false, the x labels will not be so pretty. All right, so it won't be there if you don't set x label. So the way to call it is the ax that is returned by the second plot, ax dot set x tick labels. X tick label is different from x label. X label is just what's the axis called, give it a name. X tick label will be the individual label for the tick. So these are the tick. Don't ask me why they are called the tick. Why not nails? Why not pivot? Why not whatever, right? We can call them many names. But tick is the official name. So the X tick label is going to be this series produced by give me the days. All right. All the time functions are parked under .dt, date time. So give me the days, and the d type is date time. So .dt, string format in terms of year dash month in 2-digit form dash days in 2-digit form. If you don't like it, you can put slash. You can put other percentage letters to command the string f time. Look up the documentation to print out the month name, for example, April and whatnot. Okay. So I've inserted a few highlights here. Use index equals to false, secondary y equals to true, and of course the other one is both should have the second one should have the ax equals to the previous ax. Then you are drawing onto the correct axis. Yeah, okay. So multiple plots, very, very useful, very, very powerful, and shows your skill and professionalism. And multiple plots using subplots. Here's another way to do multiple plots. But the way I mentioned multiple plots this time round is different plots on the same figure, like this here. So here you see six plots on the same figure. That means there are 6 axes on one figure. How do we do this? There are times that that show this is very, very useful. So what we can do is we use the data frame that we derived so far with ABCD, with the moving average for C and the exponential smoothing for C. So we have 6 columns. And of course, we must have a way to say, I want a 2 rows by 3 column configuration, not a 6 row by 1 column configuration, right? So how do we go about talking about that? So first thing first, have a new figure. This is the part where we start configuring the new figure. All right, so the figure is returned by plot.figure. Earlier, we just discarded it because we just used 1. But here we want to say the figure size. The figure size is 9" by 6". Why do we need this? It's more got to do with aspect ratio than actual inches. So we want it to be 9" by 6". DPI is 200 dots per inch, sort of simulating an A4 being sort of laid out in a landscape mode. All right, so 9 by 6 inches, dots per inch, 200. The idea is that when you are plotting, Matplotlib will decide to plot it very accurately and precisely, right? So you might see that this pie chart is so big. And the reason why it's so big is because I've given this aspect ratio and the dots per inch. If we set the figure size to be small, or dots per inch to be very uh, small or large, then either this pie chart will be very, very tiny because this is still maintained, the figure size is maintained, but the area that you can draw is being squeezed down because of the aspect ratio, or totally enlarged and you only see the middle, all the colors there, you don't see the labels anymore, right? So to get this nice zoom in or out effect, this aspect ratio is quite critical. So try to stick to a standard correct configuration and don't change too much. Then we say how many axes do we want and what's the orientation. It always goes with rows, comma, columns. And now I know you are now going to say, I thought you told us it's x, comma, y, and all that. But okay. So I'm not going to find excuse for Matplotlib, but this is the way it goes. So to configure a 2 rows by 3 columns figure, you simply say figure dot subplots 2 comma 3, and I call the return value axis. Axis is going to be an array, actually uh, a list of lists, right? So axis will be having two lists, two items, a list of 2 items which are themselves lists of 3 items, and each item is an axis. So for example, to refer to A here, this is first row, right? So it's axis square bracket 0, the first one. It returns a list of 0, 1, 2. So first row has 3, right? We want the first one. So square bracket 0 again. Again, this is in Python. In Python. So in Python, if you do a square bracket 0, the way it tells me is axis itself is list of axes. Yeah. So for example, if you want to refer to MA underscore C, this will be axis square bracket 1, the first row, 0, then 1, right? Then square bracket 1, because it's 0, 1. So this is the one, right? Color is slate blue, title is MA underscore C, plot the line and give an axis AX5. So AX5 is going to be axis square 1, square 1. We use title. All right, title equals to A to specify a plot title. Title equals to A equals to D equals to C. All this is to specify this title. Remember, this title is the axis title. All right. Overall, the figure can also have a sort of a family title, and this can be, for example, study of data frame to talk about individual axis titles. Yeah. So 3 things: configure the plot.figure, use subplots to design the axes, how are they being laid out, and then use title to distinguish the axes. Okay, now if you want more fanciful layout, because they're all continuous, like one after another, if you want some gap, some pre-designed gap and all this, not quite doable or not quite easily doable using the language that Matplotlib supplies. So in those cases, you might want to generate 6 different charts, 6 different files, and then stick them together using Pillow, something we are going to talk about later on.